Good evening. As a part of my first task in the machine learning internship from the Mentorness, I received a task like to build a predictive model for the disease prediction. So I have to diagnose the diseases. I have to help the doctors for the accurate diagnosis. And my data set consists of 24 attributes, 24 health related attributes. So those are cholesterol, blood cell counts, and like RBC, WBC, then platelets, then hormones and other measurements. There are of 24 measurements, and one is the label showing whether the person is healthy or diagnosed with some disease like anemia, diabetes, heart disease, thalassemia, thrombotic. There are total of 5 diseases here, so this will be coming under the multi-class classification problem. So I need to ensure the accuracy of these diagnoses and other parameters as well, like precision, recall, F1 score, to ensure the model reliability. Then going to the methodology, first I performed data pre-processing and then exploratory data analysis. After that, after all these things, I built nearly 6 models to choose the best model out of it. I evaluated the performance of all these models on the test data set, then came to know one model performing very much better. Then I took that model as a part of the fourth step. I did hyperparameter tuning, and after that I created the final model and showing the test report. So that is the conclusion. Now data pre-processing and exploratory data analysis. First I loaded all the trained dataset and test dataset files, and test dataset consists of the heart disease label, but it is not present in the trained dataset. So I combined all of them and shuffled to get much better model. And then after shuffling, I saw the information about the data. So all are the numerical columns, so no need to do anything, any encoding. And then missing values, there are no missing values in this one, and all are ranging from 0 to 1, so no need of any standard scaling. Then proceeding with the exploratory data analysis step. In this step I have plotted the count plot of the diseases. So I have seen that heart disease and thrombotic are very less samples, like very less in number. This will create a bias in the model, so we need to resample it to get the balance in the data set. Due to this imbalance, there will be bias in the model, and it will predict the most number of examples, like it will predict wrong. It will be biased against the higher examples like diabetes, anemia. These are higher in number, so it will be biased against those. So I need to resample it. I resampled using the SMOT technique, that is SMOT, SMOTE, synthetic minority oversampling technique. It is an effective method for handling this class imbalance in the data sets by generating a synthetic samples for the minority class. So for train test split, I followed the stratified k-fold, and then on the train data set I applied the SMOT, and after applying the SMOT I got the plot like this. So it is looking like very much like balanced data set. Then further going to the, these are the train test dataset shapes, and then going to the model building, I built 6 models. Those are logistic regression, KNN, decision tree in 2 criterion, and then random forest, XGBoost. All these models are built and trained on the balanced dataset whatever I did, like after SMOT whatever I got, the dataset I trained, and then their performances were observed. And then this is the first one, logistic regression, accuracy, precision, recall, F1 score. This is performing very much low, like 87, 88. Than this we can achieve better. So moving on to the next model, this is KNN model, confusion matrix, accuracy, precision, recall, F1 score. For all these models are plotted, shown, calculated. Then this is the decision tree with Gini criteria, and then entropy, then random forest, then XGBoost, and this is the comparison table. This is the comparison table of all these models, like logistic regression, KNN, decision tree, random forest, XGBoost, and from all these comparisons I came to know that XGBoost is performing well, so I am picking XGBoost for the prediction. So then I picked the XGBoost and I did the hyperparameter tuning. Then I came to know the best parameters. After knowing the best parameters, I created the final model, trained on the dataset, balanced dataset, and then tested. After testing, I got the highest score, like 99.29% accuracy. I can still tune it and get the highest score of 99.67. As shown, the best score is that. And then, but this is so much higher, so I stopped here. The accuracy, precision, recall, and F1 score are all very much close, so this model is performing better with a high accuracy of 99.29%. This is after the hyperparameter tuning. I tuned the model, then created this final model. I got these values. See, summary. So first, I did the data pre-processing, then EDA. I found the data set imbalance, so I balanced it. And then after oversampling, different models I built and then trained, then observed the performances of all these models. Of all these models, XGBoost performs better. I tuned this model to get best hyperparameters. Upon getting those, I finally created a best XGBoost model for this prediction and achieved an accuracy of 99.29%. So, thank you.